Hello everyone, this is Professor Pawan, and in this particular video we are going to discuss about the fundamentals of SFD and BMD, that is shear force diagrams and bending moment diagrams. Before going into SFD and BMD, we will discuss what is meant by a beam. Beam is a long structure which is designed to take the loads acting in transverse directions. Let us discuss about SFD and BMD now. Consider figure 1, which is a cantilever which is subjected to various point loads. Let XX be the section of interest. Now, shear force at section XX is defined as algebraic sum of all the shear forces which are acting either towards left or towards right side of this section of interest. This is called as shear force. Now, the diagram which represents the variation of shear force throughout the beam is called as shear force diagram. Let us come to bending moment and bending moment diagram now. Consider figure 2, which also is a cantilever, and here let it be subjected to some point loads as well as some moment here. Let YY be the section of interest now. Now, bending moment at this section of interest, which is YY, is defined as algebraic sum of all the bending moment due to forces and moments which are acting either towards left side or right side of this section of interest. Now, let us discuss about the various types of beams that we come across in this particular subject. So, the first beam is a fixed beam which you are seeing here. This is nothing but a beam which is fixed on both its ends. Okay. Let's come to the second type of beam, which is called as a cantilever beam. A cantilever beam is the one which is fixed at one end but free at other end. The third kind of beam is the simply supported beam, where a beam simply rests on two supports as shown in figure. The simply supported beam can also be represented as a beam which is hinged at one end and has a roller support at the other end. Finally, we have this one more kind of beam which is called as overhanging beam. Here, the beam which extends beyond the supports is called as overhanging beam. Now, let us discuss about the types of loads that we come across in this module. Okay. We have basically three types of loads. The first one which you are seeing in this figure is called as point load. Okay. In this beam, we have the various loads P1, P2, P3, and they are acting at those particular points A, B, and C respectively. So, the loads which are acting at one particular point are called as point loads. Now, consider this figure, that is figure 2, wherein we have a load which is acting uniformly between the two sections. Such load which is uniform along the beam is called as uniformly distributed load. Here, the magnitude of UDL is W per unit length, which is nothing but load intensity. Now, if we want to find the equivalent load or point load from the UDL or uniformly distributed load, we have to multiply this W into the length along which it is acting, that is W into L is the equivalent load of the UDL or equivalent point load of the UDL. Also, it has to be noted that this point load or equivalent load of UDL acts exactly at the center of this UDL, that is at the midpoint of its UDL, which is L by 2 in this case. Now, the third type of load that we come across is called as uniformly varying load. Consider this figure 3. We have a beam of length L and it is subjected to uniformly varying load which varies from 0 at one end to W per unit length at other end. Now if we want to find out the point load equivalent or load of this UVL, we can do it by finding the area of this UVL, which is nothing but half into W into L, or basically half into L, which is base, into height, which is W. Now here the location where this UVL or the point load equivalent of UL exactly acts is at a distance of L by 3 from the bigger end, that is this bigger end, or 2 by 3L from smaller end. Next thing that we will discuss is the sign conventions that we generally use while drawing shear force diagrams and bending moment diagrams. First we will discuss the sign convention for shear force diagram. The sign convention used for shear force diagram is very simple. Let us say we have a beam like this here, and let us say that this XX is the section of interest. Now the load which is acting onto the right side of this section and it is acting downwards is assumed to be positive. Okay. Now this makes the rest of the things quite obvious, like the load which is acting onto the right side and upwards will become negative. The load which is acting towards the left side downwards becomes negative, and load which is acting left side upwards becomes positive. Although you can remember it in very simple manner that right side downward load is positive, so that you can avoid the confusion. Okay. Now let's come to the sign convention used in bending moment diagram. It's also quite simple. The moment or couple which is acting anti-clockwise direction is taken as positive, whereas the clockwise moment is taken as negative moment. Also, we'll have a look at this table, which will be quite helpful for us while drawing the SFD as well as BMD. Now, what it says is, when the type of load under consideration is point load, the shear force will be constant, or the shear force diagram will be a constant line. Whereas the bending moment diagram will be linear variation, that is an inclined line. If the type of load is UDL, that is uniformly distributed load, the shear force diagram will be having linear variation, or basically it's an inclined line. Whereas the bending moment diagram will be having the parabolic variation, which is nothing but represented by the parabolic curve. If the type of load is UVL, the SFD can be described by parabolic variation, that is a parabolic curve, whereas the bending moment diagram varies by cubic variation, that is the cubic curve. Thank you. If you like the video, do hit the like, share and subscribe button.